Hello everyone, and welcome to a video about the addition rule. This video will discuss the addition rule as well as a table sourced from Elementary Statistics by Mario Triola, and you can find that on page 150 in the text. Our outcomes for this video are to be able to identify the addition rule by both informal, formal, and geometric representations, understand the rule of complementary events, and calculate probability using the addition rule and a chart. So the formal definition of the addition rule is that the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. So this is a very formal mathematical definition, and it's more easily described as the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B occurring at the same time, an overlap. Now, these are both sound very formal, so we're going to also do a geometric interpretation of the addition rule. So if I have two figures, this ellipse and this ellipse, and we'll say that this one represents the probability of A and this one represents the probability of B. That means that this overlap here in the center is the probability of A and B. So if we were to take just the area of these figures, we're ignoring for a second that they're representative of probability of two separate events, that when we took that area, we wouldn't count that middle portion twice, right? We would only want to count it once, either when we took the probability of A or the probability of B. But if we took it twice, we would end up with more area accounted for than we actually have because of that overlap. And that's a good way to think about it. You really want to think about it as an overlap. So I've got this table here, table 4-1, which you can find on page 150 in the 12th edition of the text, which has 4 outcomes from some pre-employment drug screenings. So we have positive test results, negative test results, and the fact that the subject uses drugs or does not use drugs. So if we wanted to calculate, for example, the probability of a positive result, that is this column, or that they use drugs. So we would have to find the sum of this column and this row, and we want to subtract out the overlap. So first we want to find the sum of each column and row, and then we want to find the overlap, and we're going to subtract them as fractions. So the sum of the positive test column is 134. And the sum of the subject uses drugs row is 50. So the total for this is 1,000, so we'll write n equals 1,000. So we have 134 over 1,000 plus 50 over 1,000. And then we want to subtract out the overlap, and that overlap is right here at 44. So we're going to subtract 44 over 1,000, which gives us a result of 140 out of the 1,000 either used drugs or had a positive test result. And if we wanted to do the same problem a little more intuitively, we could simply see that for a positive test result or subject uses drugs would be the sum of these 3, and we would simply be smart and just ignore the overlap instead of adding it in twice, and we would just say it's 90 plus 44 plus 6, which is 140, and we know our n is 1,000, and we get the same result. So the last thing I want to leave you with today is the rule of complementary events. And it's informally, it just says that any event, A, and its probability, plus the probability of all other events, that is to say A bar, must add up to 1. And this makes sense because we know that when we're trying to mathematically deduce probability that we must account for all outcomes. So we write this as the P of A plus the P of A bar, that is the complement of A, must always add up to 1. And if we wanted to see a geometric representation of this, if I have this rectangle, and I'm going to say this area total is equal to 1, that if I have an oval in the center, which is P of A, and the area outside it, all around it, but not inside it, I'm going to call that the P of A bar, so that this oval and the area around it must add back up to 1, which we can see. Once again, I just want to remind everyone that we always have additional resources here at Middlesex Community College. Our website, where you can find schedules, tip sheets, and additional information. The Bedford Math Center and the Lowell Math Center are available most of the summer to help, and E-Tutoring is always available 24/7. Finally, I will be linking a tip sheet to this video's description to cover this video and the next video.